Hi, good afternoon, everybody. My name is Nathan Glashinsky. I am the Senior Process Management Specialist with Mercy Technology Services for the Mercy Health Ministry. I have been with Mercy for 17 years, and I should probably, did I share my screen? I apologize. That would definitely be helpful. Like I said, I've been with Mercy for 17 years and in technology for 10 of those years. In my time, I've held several roles that include security officer, help desk analyst, incident management, and clinical software business analyst. An opportunity presented itself to attend Savvy Coders to further my personal and professional growth. In early 2017, when my technical knowledge shifted from a support role to more of an analytical capacity, I began to understand the importance of learning why, especially now within my present role as a problem manager. I get to look through the data, find the root cause of issues that impact my organization. And now that now that I have cultivated my new skills and continue to grow, I will be able to dig further into the data than ever before, finding where IT services can be improved and present that data for business leaders to make actionable decisions. I chose to do my capstone on vehicle crash data from the city of Chicago. I chose this data set as I am keenly interested in the ability to map out the various areas and trouble spots in the city limits while commuting, how the time of day and given weekdays impact the number of incidents, as well as weather-related impacts to the crash data. I did have the pleasure of visiting Chicago once in 2018 with my son, Cody, when he turned 16. He's quite the luxury car aficionado, and we took to the weekend to tour the various high dollar luxury car dealerships in the city. While we were there and had a great time, the traffic was a nightmare. One of the major sticking points to visiting Chicago was definitely the traffic, and then how much it costs to park in the city limits of Chicago. I was able to gather my data from the city of Chicago's data portal. There I was able to find related information about traffic crashes that I would use to pull into Python and into Tableau to present for my capstone. The full data set is comprised of about 655,000 rows of data, which is quite sizable and very difficult to manage. I took this data knowing the size of it was going to be too large and was able to clean the data set using Excel functions taught in Savvy Coders. I was able to remove about 571,000 of those rows, along with any null or empty cells or bad data. I used Python in my data preparations to import the CSV file as well as pandas into Python and was able to count the number of rows and columns in the data set. This helped me understand the baseline contents of the file and returned information showing me a row count of 118,503 and a column count of 17. While reviewing the data set, I noticed that the column names were not in the friendliest of formats. So I used another Python script to bring me the printout of the column names. And then using a third Python script, I was able to have Python rename all those columns into more readable or understandable terms, and saving that information and removing some other fields that were not relevant to the data I was trying to understand. I was able to reduce the final data set contents to 83,853 rows. I added here in the Tableau website, or excuse me, in the Tableau presentation of the website of current traffic statistics for the city of Chicago. That way it gives us a live view of the current headaches that most Chicagoans are facing at this moment during this particular time as I'm actually going through my capstone. For our first map, I had decided to map out all the traffic incidents using latitude and longitude information from the data set that was provided. I wanted to better understand the breakdown of crashes by severity, so I took the data points and split them into 4 separate groups. I have crashes with no injuries reported, crashes with minor or non-incapacitating injuries, crashes with major or incapacitating injuries, and crashes that came back with fatalities. This first map here shows us the full list of all accidents over the last 13 months. The count is 82,853 incidents. When calculating those facts, it translates to about 209 crashes per day and 9 per hour. This map here shows us the location and frequencies of those crashes that occurred where no injuries were reported at the time of the incident. It represents a count of 65,052 crashes and gives us a 79% non-injury rate. This next map shows the location and frequencies of crashes that occurred where minor injuries were reported at the time of the incident. This represents a count of 8,629 incidents and a 10% injury rate. This next map shows the locations and frequencies of crashes that occurred where major or incapacitating injuries were reported at the time of the incident. It represents a count of 1,985 vehicle incidents, giving us about a 2% major or incapacitating injury rate. This final map is a little harder to view. While I was preparing for this presentation and looking through the data, it took me back a little bit because I do have a couple of new drivers in the household. And when reviewing the data and looking at the next map, I was able to go back and tell my kids, hey, make sure you're careful when you drive. This map shows us the fatalities that were reported at the time of the incident. The count is 158. That gives us a 0.2% fatality rate. So when is it safe to drive? I asked Tableau to help me understand that. And when I ran the data through, it was able to give me the safest day that it was able, the safest day that everybody should be able to be on the road with the least amount of risk, and the days of the week that are the most risky. Sunday definitely is the safest time as well. Opposite of that, Friday is not so much. I guess everybody's in a hurry to get to the weekend. I asked Tableau again to help me understand the time of days that driving is the safest and when it's the riskiest. The safest time is between 4 and 5:30 in the morning, and the most riskiest between 3 and 5 in the evening. Then I asked Tableau to understand how weather played a factor. I wanted to highlight how the accidents versus the days of the week with the weather implications. And it was an interesting observation when I ran this report, because contrary to popular belief, clear weather is the most reported as having the greatest number of related incidents, with rain coming in at a very distant second, and then winter precipitation barely scratching the surface on the total counts. I also wanted to correlate the time of day where weather conditions played a factor in the crash data. So I was able to create another chart that gave me the time of day showing the 4 to 5:30 a.m. rush hour morning traffic being the safest, with the afternoon and evening being the most risky. I do want to thank everybody and Savvy Coders for the opportunity to go through the cohort and present my data to everybody this evening. I am sincerely grateful to the instructors, administrators, and to the program, the opportunity to learn these new skills. I learned several new tools. I learned how to look at data and how data can be used to tell us stories about things we don't know or things that we thought we knew, especially when it came to the fact that it was more dangerous to drive in clear weather versus rainy weather. And with that, I would like to say that if you ever find yourself in Chicago and unfortunate enough to have a vehicle-related incident, I first pray that you're okay, but I did tell you that it was risky. I definitely thank everybody for their time, and thank you very much.
That was great. That's really, really interesting information. Does anybody have any questions for Nathan before we move on to the next presenter? Yeah, sometimes there are, and sometimes there are not. Great presentation. Thank you so much.
Thank you, guys.
Okay, the next presenter is going to be Deja McClendon. Whenever you're ready.
Okay. Give me 1 second. Okay, can everybody see?
Yes, ma'am.
Okay, great. All right, you guys. So as you can see in the chat, I sent a link down below. So if you guys want to go ahead and just do that real quick before I actually start my presentation, that would be amazing. I'm just going to give everyone like a minute because it's very short. So. All right, I'm just going to go ahead and get started in. So hello, everyone. My name is Deja McClendon. I want to thank everyone who came here today, who spent the time out, one, to teach us all this valuable information, and two, all the people who are coming here to support myself as well as my other classmates. Again, my name is Deja McClendon, and I spent the most of my career in the medical field as a nurse tech at local hospitals, a social media content creator, as well as a financial risk advocate in both Columbia and St. Louis, Missouri. My interest in the tech industry started because I was interested in transitioning into a new line of work. And also, my mother was a data engineer for about 15 years. And because of her success in the field, I knew that this would be a great path for me to take. While researching, I saw a lot of great things online about Savvy Coders and the classes they had to offer. So I figured that I will take the time to utilize the classes that they had to actually start to pivot my career into a different direction. While taking the data analytics Python cohort with Savvy Coders, I learned how to utilize multiple programs and adapt to the constantly changing language of Python, because we all know how complicated Python can be. But with that, I learned how to create, pull, display, and analyze a bunch of different information. Since I was a young girl, I've been extremely fascinated with the beauty industry, and I've spent a lot of my time learning about it. And I figured I would combine my first love with this newly acquired skill that I've learned. For my capstone project, I will determine what category is favored amongst Sephora's online store, beauty or skincare. And I will also talk about what brands encompass that winning category and what is the top rated low and high end product that's there. These answers will be analyzed through human interactions, incorporating ratings and loves. So the reason I decided to base my presentation around Sephora's website and only narrowing it down to makeup and skincare categories is because most of the products and tools that you see, most of the products and tools that fall under body care as well as hair care can be found on either Amazon and online Amazon or in a drugstore, so much cheaper. And then the products like perfume and hot tools, that's not something that people are, going to Sephora to replenish over the course of a few months. So I figured it was best to just stay in the makeup and skincare category for this presentation. So to clean my data, I started out by finding my data on Kaggle. And once I found a CVS file, I went ahead and downloaded it. And then I used the pandas form on Python so it can read it. And then from that, I use the pandas drop method in order to remove any unnecessary columns. So as you can see in this screenshot, even though it's like super small, you can't really make out what it's saying. You can see that there are a lot of different categories that was just included in the data set. And so with this screenshot, you're going to see here that I use the pandas drop method in order to drop the skipped columns that you see and keep the ones that I wanted, like brand, category, name, rating, price, and love. And then up here, you'll see that I still stayed in the pandas code, and I used it to I use a data frame sorting function in order to organize all the products that was in the category column in ascending order alphabetically. Alrighty. So for my final cleanse, I use the same exact drop method in order to remove. Actually, let me go back because I want to show you guys one more thing that I use the drop method for. So this is the drop method that I use again, just so I can remove any categories that had nothing to do with makeup or skincare, because that's pretty much just was going to ruin the entire analysis, and I didn't want anything unnecessary in the data. So now moving on to the final cleanse, I use the same exact drop method from pandas to then separate the categories into their own team. So you have a skincare team and a makeup team. And so for the skincare team, I went ahead and used that same drop method and pretty much removed everything that had to do with makeup. So blushes, eyeshadow, face primers, you name it. So once that was dropped, then it created this file right here that had only skincare. I did it again so we can create the makeup category and did the same thing. I used face oils, eye masks, eye creams, anything that had to do with skincare, and it was dropped so it can create the makeup category. So before I get into the poll results, does anybody want to guess what they think the winning category will be? Anybody, just say any category, skincare or makeup?
Skincare.
Okay. So let's look and see what y'all think that it's going to be first before we actually give you the real data. Wow, I was not expecting that. Okay, so it's pretty much 50-50. Some people think it's going to be makeup and some people think it's going to be skincare. So let's look at the actual data and see who actually won. Now, if we're just considering the sum of loves only, from this display that I'm about to show you, you can clearly see that makeup took the gold. It won by a long shot, honestly, because that's 80 million compared to a measly 26 million. So for those who chose makeup, congratulations, you chose right. This is the most favorite category that is on Sephora's online website. So this is what people are going online to shop for the most, as opposed to any other brand or category of brands that may be on there. Now, if this doesn't convince you enough, I'm going to show you some more data in order to, further solidify it. So if you look at this bar graph display, the illustration shows you that even if we do consider this sum of ratings between the two categories, makeup still holds the title as being the most favorite category that people shop in. Although makeup didn't completely destroy skincare like it did in the previous display, it does still have a clear indicator that makeup is favored more. Moving on to another display. Since we now know which category is favored in this tree map display, I'm showing you the various brands that encompass this category. From the darkest purple shade, it represents the largest count of makeup in the actual brand, and to the lighter purple shade, which is the lowest count of makeup. Which in my opinion, this makes a lot of sense that Sephora's collection would be the largest makeup brand that's actually housed in the company, because if you're thinking business-wise, a lot of their goals is to keep a lot of their money to themselves and not have to split it amongst other contributing brands and stuff. So yeah, if a company wants to make more profit, then it is best for them to have their own luxury brand in order to, profit from a lot more of the sales. And let's get into the troubleshooting. So before I actually tell you guys what the top rated low end and high end product is, I actually ran into some issues with my code because I want to use the same drop method in order to show you guys what that answer would be, and it just did not work for me. I tried about a good 3 times, and I even asked my teacher to help me out with it, but she was busy at the moment, so I had to think on my feet and try and figure something else out. So instead of waiting on her and getting upset, I went in and tabbed below and utilized their filter functions in order to filter out what I actually wanted. So as you can see in this code, I wanted to remove any and everything that was under 5 ratings. So you can see I removed 1, 1.5, 2, and so on and so forth. And here in the actual final code, final display, you see a 3 here, 4.5s. At one point I saw a 0, and I was kind of defeated at that point, because I was thinking to myself, okay, I did the code right, it worked, so why isn't it showing up? But after I put in the filter and I only filtered it for 4.8 to 5, then it ended up working in my favor, and I was able to show you guys exactly what I wanted to get across. So for the last bar graph, horizontal bar graph, this is going to display the 5-star rated products in Sephora. As you can see, there are lots that are rated 5 stars, but we're only worried about the most expensive thing and the cheapest thing. So we're going to start on the low end first. So the cheapest thing you can possibly get from Sephora is the Colorful Gloss Lip Balm. And this is actually a Sephora brand. And I only know that because I work for Sephora now. And had I not worked for them, I wouldn't have realized that there was a Sephora brand. And it's priced at $9. And you can't get any better than that. As far as the most expensive thing that is at the store, it is this Grande Pro Volume 3 palette for $175. Now, I don't know about you, but I don't really know who's paying that much money for a makeup palette, but I thought it would be interesting to just show you guys what the price range is in that store. Now, before I close out, does anybody have any questions for me? All righty. I want to say thank you to the administration, my teacher at Savvy Coders. You guys have taught me a lot. Thank you again to Ashley, because Ashley, I have struggled throughout this entire cohort, and you have made it super enjoyable to just learn a whole different language and learn an entirely new field of information and stuff. And then your pep talks and cheers are always what motivates us to continue pushing on and continuing to work through our issues with coding. So thank you again. And I'm so grateful that I even got to experience this.
Great job, Deja. That was a fantastic presentation. Thank you.
Thank you.
Okay. All right. Well, moving along, we have our third presenter, which is Jimmy. Whenever you're ready.
Hello, everyone, and thank you for coming. My name is James Daly. You can call me Jimmy, and I'd like to share with you a bit about myself and the events that have led to where I am now. Previous to my involvement with Savvy Coders, I was an executive chef and spent 25 years in the hospitality industry. In January 2019, I was involved in a head-on collision, got my noodles scrambled, had major surgery on my neck. I'm not trying to diminish what happened to me, but I didn't let it define me. The accident ended my culinary career, and I had to relearn a lot of things that I previously took for granted. I spent over a year going through various therapies, physical, vestibular, cognitive, and speech, and fought hard to get where I am now. After my surgery, I had a lot of time to think about what the future of my life would be, so I drew from my childhood, where my greatest interests at that time were cooking and computing. I went into the culinary arts, and now that part of my life is over. I do still cook at home, but then I sought out computing as the next chapter of my life. I started with a boot camp in July of 2021 in full stack web development and completed that in April of this year. But I was driven to learn more. And then I found Savvy Coders in the data analytics and Python boot camp through Meetup. And I'm very glad I did. Web development gave me a good coding foundation. The data analytics and Python boot camp gave me an obsession. So that's me in a nutshell. Let's start the show. All right. So I want to take a moment and acknowledge that there are images and expressions of alcohol and marijuana use in this presentation. So they're intended to be humorous, however, they may be harmful. If any of you in any way feel triggered by these areas of discussion, I want you to know that I care about your feelings and there's no judgment whatsoever if you want to leave, because your health is important to me. I want to have some transparency here. I didn't start out as a UFO enthusiast, and I'm not sure that I am now. However, something happens to a person who is open to the idea of alien encounters and UFO sightings. As I went down the wormhole, things became a little distorted, a suspension of disbelief formed, and then things got weird. I don't really remember how I got the idea of doing UFO sightings or how it snowballed into what you're about to see. I will say that once you take the leap, it gets stuck in your head. It didn't start as a passion project, but it turned into one. The more I read, the more I wanted to know, the more I wanted to believe. It also became something where I wondered how or if alcohol or marijuana played any part in sightings. After all, some people might say, go home, spot, or what are you smoking, man? Whatever. And so that's what we're going to talk about tonight. Also, when I say things about sightings, these are reported sightings, not because, and it's because not everyone has reported what they've seen. So let's get started with alien travel agents. This is Expedia, but for aliens. As you can see, and as far as booking sites go, UFOs tend to like areas in the US more than others. Specifically, they like Washington State the most. And what's there not to like? It's a pretty cool place. It's got Pike's Market, Starbucks, Mount St. Helens, Olympic National Park. It also has the Space Needle, which is probably their favorite attraction. Then we have Florida, Walt Disney World, Miami Beach, the Everglades, and of course their favorite site, Kennedy Space Center. And of course, next is Texas, the Alamo, Padre Island, Dealey Plaza, San Antonio, Dallas traffic, and of course another favorite, the Houston Space Center. Move on to New York, obviously the Statue of Liberty and other New York attractions. They have Niagara Falls and the Catskills, and if I recall correctly from the movie Independence Day, the aliens weren't too keen on the Empire State Building. Finally, we have Illinois, which has the Willis Tower Sky Deck, Navy Pier, the Lincoln Library, Magnificent Mile, and addition Springfield called the Horseshoe. I've tried it. It's nothing to write home about. These are the 5 states we're going to look at tonight. Reported sightings have increased over the years as we come to the present day. This is likely due to mainstream acceptance of their existence and reporting centers like Newport, which is the National UFO Reporting Center. Their database stretches back to the 70s and has collected approximately 90,000 reports. By the way, this is us in Missouri. We only have 1,458 reported sightings a year. So our otherworldly visitors seem to be somewhat courteous, as they don't typically bother people as much during the day as they do at night. During the day, the number of sightings are much lower than the hours between Miller time and bedtime. So why is that? It's assumed that most people work inside during the day. There are daytime sightings, but far less than the hours from 5 p.m. to 11 p.m. There's a small jump between 5 and 6, but from 7 to 9, the sightings increase, and then in peak with 249 at 11 p.m. And they drop significantly at midnight. We assume that everyone has gone to bed. Sightings at night may also be explained by the contrast of a bright glowing object against the night sky. So it's pretty courteous of the aliens to limit their visibility to the hours following work. Now I have a peek at the state-by-state consumption of alcohol. And these numbers are averaged taken from 2020. They are also measured in gallons of all varieties of alcoholic beverages. As you can see, most of our states cluster right here in the middle. Nothing too extreme, unless you're New Hampshire, which comes in at about 4.7 gallons per person per year, which is what Chuck Norris calls a slow Tuesday. Other state outlier state is Utah, coming in right here at a respectable 1.35 gallons a year, which is good for them, I suppose. Missouri comes in at a modest 2.5 gallons right here. Just for reference, a 12-pack of beer is 144 ounces. A gallon is 128 ounces. So these numbers really don't equate too much over the course of a year. Not everyone drinks and the amounts are average. Something to consider is that people who are surveyed about alcohol tend to downplay their actual consumption, whether they forget how many they've had, have a fear of judgment about usage, or they purposely evade the question. So, all 50 states show between 12 and 25% of their population using some form of marijuana. And like alcohol, the numbers show that most of the states cluster in the middle, unless you're Vermont, which comes in at a whopping 30%. I understand there's some hippies in the state, but I mean, that's crazy. They do have Ben and Jerry's, which actually might be an enabler. There are other outliers, of course, and one variable is about their usage is legality, whether it's medical or recreational in those states. Also noted about alcohol consumption, some people are hesitant to report usage accurately. Missouri comes in at 16%, so it's right in the middle. And it's just a hair above the national average. Right now, let's take a look at our top 5 states for alien vacations and how they stack up against each other. So here we are with the states with the most UFO sightings and how much marijuana and alcohol they use. Across the board, alcohol in these states is pretty close. The variations are slight, but marijuana. Again, we have to take into legalization, utilization, and accuracy in reporting, but the numbers are in percentage of the population using. While legality plays a part in accessibility, where there is demand, supply will follow.
Your sound turned off.
Uh-oh.
Nope, I can hear you.
Oh, okay. All right. Let's see, where was I? Washington State. They have the highest number of UFO sightings and the most people using marijuana out of them. Florida has second most sightings, but just 16% of their population uses marijuana. Texas, low usage and low alcohol. And I don't know any cowboys, but I doubt there's one that said, "Hey, Clem, call the sheriff. I just saw a UFO." The marijuana usage in the final 2 states, Illinois uses more than New York, but they both have fewer sightings. Nonetheless, they still rank in the top 5, but Washington needs an intervention. Does their imagination or marijuana run wild? Perhaps both. I started to wonder if marijuana and alcohol usage actually influence where aliens decide to take their vacations. Maybe their planets are boring. Perhaps humans that see their fancy vehicles are only watching aliens having a good time. But back to the topic. Does their total consumption of alcohol and marijuana lead to more sightings? It's doubtful that aliens only show themselves to drinkers and those who ingest THC. It would make all of those individuals less credible witnesses. And why would aliens target them specifically? And how would the aliens know if the people who reported the sightings were messed up? We also have to think about the size of the audience who witnessed the UFOs. Not everyone is drunk or high. It's just not possible. Another thing to note is that New Fork's reporting form doesn't ask about sobriety. They don't also ask about education level, accuracy of their vision, or their psychiatric history. So it'll take a second to load. Here are some images of UFO sightings. In the top left, we see the Phoenix Lights. This happened on March 13th, 1997, and just below is the flight pattern. This was viewed by hundreds of people from the southern tip of Nevada to the northern part of Tucson. One witness reported a strange cluster of distinctly red-orange lights, which consisted of 4 to 5 red lights in the lead, followed by a single light that followed behind. The operator at the reporting center described the man as a rational, sober-minded, and eloquent-sounding person. No engine sounds were reported from the objects, and they were noted to have been less than 1,000 feet off the ground. The objects were also reported to be hovering, but weren't man-made. They weren't weather balloons due to the speed they traveled at. According to witnesses, they weren't of this earth. The images on the top are from a very recent sighting that happened on September 19th, just a few weeks ago. This was witnessed by hundreds of people from San Diego to Tijuana, Mexico. The images below are 3 separate incidents captured by naval aviators. This one on the left, FLIR, which means forward-looking infrared radar, was recorded in 2004 by Commander Chad Underwood. He nicknamed it Tic Tac because of its color and shape. In an interview, he said, quote, "The thing that stood out to me most was how erratic it was behaving. And what I mean by erratic is that it's changes in altitude, airspeed, and aspect. It was just behaving ways that aren't physically normal." Next to this is gimbal. Pay attention to this right here in the center. The name comes from axis movements, yaw, pitch, and roll. And you'll notice that the UFO pitches 180 degrees while in flight without gaining or losing altitude, which is physically impossible with current aircraft. Go fast is pretty self-explanatory. It traveled at an altitude and speed that isn't possible with modern aircraft, and it wasn't a missile. The point of showing these images are the individuals who reported them. The amount of people who reported them that could not all be impaired, and much less the naval aviators. Outside of pilots and citizens on the ground, there are many PhDs and high-ranking military officers who have witnessed UFOs. It's hard to call into the question the level of their education, in some cases their sobriety. There's a little graph displaying the results of a survey taken recently. As you can see, most people believe in UFOs, 39%. Some are, and then almost the same amount, which is 35%, that say no. There are still some that are on the fence, coming in at 26%. And then my favorite are the 1% that said, I'm not even going to think about it. Looking through all the data and trying to make a logical argument that using alcohol, marijuana, or both at the same time has anything to do with the amount of sighting is pretty thin. They can't all be drunk or high. From the average person to the fighter pilots to PhDs and so on, there isn't a correlation. Maybe some, but not all. And to add to that, people really don't like it when they're trying to tell a good story and someone says something like, what kind of Sao Paulo North Slope tripweed are you smoking? Or was this on St. Patrick's Day? People want to report their sightings. They want to report their sightings when they think they might be discredited. I know I wouldn't want to either. I'm just going to touch briefly on these methodologies. The UFO data came from New Fork, and it was in comma-separated values, or CSV format. It had thousands of rows and 9 columns of data that reached from time and date, shapes of the UFOs, to personal accounts of what the witnesses saw. Cleaned these up with a reusable code written in Python, which also connected and created a database in SQLite. In one of the data sets, I used Excel, got a migraine, and went back to SQLite. All of the sets were exported in CSV files and then imported in Tableau to create what you see tonight. In order to use the custom GIFs I made, I had to create a static HTML website using this code, publish them to the internet using GitHub pages, and then attach them to dashboards in Tableau. Also is pictured me working in Excel. As you can see, I used a lot of sources, namely the New Fork, the National UFO Reporting Center, and SAMHSA, the Substance Abuse and Mental Health Services Administration. Also a lot of photo and film credits. Next is just a little presentation to express my gratitude to Savvy Coders and everyone involved. Thank you for being here tonight. Also, if you'd like to review this presentation or look me up on LinkedIn, next is where you can find me. Congrats to the cohort and much gratitude to my wife and cats. Live long and prosper.
All right. Does anybody have any questions for Jimmy?
No questions, but that was freaking amazing. I loved that. And I love the purple and green. Yeah, you did that.
Thank you. Thank you very much.
It was a fun presentation, Jimmy, and I loved all the graphics you used and all that stuff.
Oh, thank you so much. Thank you very much. It was a lot of fun to make, and I'm glad you all enjoyed it.
All right. Great job. Thank you for sharing. Okay, next up we have Amir. Whenever you're ready.
Sure. Let me start sharing my screen. It's not easy to go and present after Jimmy though, just wanna say that. Okay, hi everyone, good afternoon. Thank you for your time. My name is Amir. I'm a senior business architect consultant with Uncommon. I have a master degree in industrial engineering and an extensive background in supply chain management and ERP systems implementation and management. Especially in manufacturing environments. During all my career, I have been working with data engineers, data analysts in different capacities. And I always wanted to enter this amazing skill set and kind of add it to my arsenal. And this was a great opportunity. I was introduced to Savvy Coders by one of my managers at Uncommon. And then I got to know this great bootcamp and I started doing that. I'm very happy for this opportunity and I think I really learned a lot. My capstone is about Airbnb market in New York. So there are a couple of reasons I chose that. I've been thinking about investing in Airbnb markets, not necessarily in New York for a while. And also me and my wife, we love New York. So anytime I can convince my wife that we don't need to go on the beach, New York is the second best answer all the time. Even if we have only like a long weekend, 3 or 4 days, we're gonna go there, get some good pizza, go to Little Italy, go to Chinatown, enjoy the coffee, enjoy the food, and then come back refreshed. So also another major reason was I found a kind of good data set on Tableau Public about the Airbnb market in New York. The data set was around 400,000 records. It had around 400,000 records, but it was pretty clean data set. It didn't really have that much noise. It just had some vacant information, some rows that didn't have all the information. So first I started like writing these complicated for loops to go over each line and each column to mark the vacant cells and then delete them. And then I found like a one-line function that I just could drop all the lines that doesn't have all the information. So that's why my code for this project in Python wasn't really that long. I guess that's called learning. So instead of that like 40, 50 line for loop, I just used that function and my data was clean. So from 400,000 record after cleaning, the data was around 280,000 records. So first, let's look at the different type of units at New York City. As you can see, and by the way, I have around 22,000 units in whole New York City. Around 85% of them are apartments, which is obviously is the case in New York because of the price and the way the whole city is structured. After apartment, you have houses, lofts, and bed and breakfast. And also you have like these word named units for probably marketing like castle, chalet, hut, lighthouse, cabin, and other stuff. So this is the map of New York divided by zip code area. On the right side, you can see the 5 major boroughs: Staten Island, Brooklyn, Manhattan, Bronx, and Queens. On the left side on that map, you can see the number of units, the distribution of number of units per zip code. So the darker, the more red means you have more units, more Airbnb units over there. So as you can see, there are a lot of, the focus is usually on Manhattan and northwest of Brooklyn. So Manhattan is obvious, there are a lot of businesses over there. There are a lot of scenery, there are a lot of landmarks, good museums. Like, you are probably 5 minutes away from a good pizza place anywhere in Manhattan. So why wouldn't we? I love Manhattan. And also Brooklyn, also there are a lot of businesses over there, and the Brooklyn is very close to the financial district, which is south of Manhattan. So that's why a lot of people kind of go there, because they can get to financial district probably in less than 20 minutes. So keep this in mind. So this is the number of reviews per zip code. So I'm presenting number of review. I'm kind of meaning that, saying, okay, if I have more reviews in one zip code, then that means there are more people going to that zip code. So the darker, the more blue, the more reviews you have. So let's put these two together. As you can see, in those location and zip codes that you have more Airbnb places and location and units, you have more reviews. So based on who you are and how you want to see this data, you can actually talk about it from 2 different perspectives. You can say, yeah, most of the people go to like Manhattan area because there are more properties over there, because there are more Airbnbs over there. Or you can say most of the investors are going over there because more people are going to Manhattan. Again, none of them are lie. Both of them are correct. Both of them are fact. It's you as a data analyst who choose how you want to present that data based on your audience. So next up, let's take a look at the average review. So average review means all of the people who gave reviews in a certain zip code, we took an average of that. Again, the darker, the more green, that means the higher the average of the review is. That means you get better quality Airbnb locations. So as you can see, those are scattered all over the place. You have some in north of Bronx, you have some in north of Queens, you have some on the west of Brooklyn, south of Staten Island, and you have some scattered in different sections of Manhattan, like the financial districts, and also south of Queens. Also, one thing I noticed is, if you can pay attention on those zip codes that they have seen to the water, to the ocean, or to the sea, they actually have, most of them have higher reviews. People enjoy having the view on their balcony, apparently. So going to the next slide, on the left side is the map we just saw. These are the reviews, the darker the better. On the right side are the average price per night for each zip code. So let me tell you a story. Most of the time when we want to go on a trip, my wife kindly put together like 5 or 6 Airbnb or hotel suggestion, and like I'll meet all of the rest of them and say, hey, these are the best options that we have. Help me to like choose one of them. And I'm lazy, and most of the time I'm like, just go with the most expensive one. Those are usually the best one. So this picture proves that I'm wrong, and I am probably paying more and not getting enough quality. If you pay attention, as we saw, there are a lot of good and high review locations and units. For example, in north of Bronx, in this location. But these locations are not necessarily that expensive. So on the right side, if it is more red or if it is darker, those are usually, that means they are more expensive. So as you can see, there are a lot of good review, high review units or zip codes that are not necessarily expensive, like north of Bronx, or over here, you see, for example, these have good review, but it's not that expensive. Or this one, like it has a high review, the average is 96%, but it's not expensive at all. On the other side, you can see zip codes on Manhattan that are actually not very high. It's one of the lowest on average review, but it is expensive. So you can see the heat map on the right side. You have a lot of reddish area in the Manhattan, but you don't see a lot of dark green area in Manhattan. So again, that the moral of the story is just pay attention and take some time and read the reviews and check the best, probably choose the best review. Don't necessarily go with the price. So this bar chart kind of represent the same message. On the left side, we have the average review per neighborhood sorted from best to worst, and on the right side we have average price per night per neighborhood, sorted from highest to the lowest. So as we saw, Brooklyn has the highest average in reviews, but it's not necessarily the most expensive one. It's actually in the middle. It's the third one. On the other hand, Manhattan is the most expensive one, but it's the second one in terms of high review. So proving the same idea. So this is a scatter chart. Each dot is actually an Airbnb unit. On the x-axis, you see average review per night. Average review per host ID. And on the y-axis, you see the price per night. So one interesting fact over here is, if you can see on these certain percentages, 60%, 70%, 80%, 90%, and 100%, there are a lot of properties that are lying there, especially because of their average rating. So these are number of star and half a stars that people give out. And because everybody has tendency to either give out a whole number or just half a number, that's why you get a lot of Airbnb units in these. This is 3 star, this is 3.5 star, this is 4 star, this is 4.5 star, and this is 5 star. And what this chart shows us is there are a lot of properties over here which we would love as a consumer, as a renter, because they are high in review, but they are low in price. So again, if you pay enough, if you pay attention and if you spend enough time, there are a lot of good properties that you can find with a lot of other customers being satisfied, but you don't necessarily have to pay crazy money. With that being said, that was my last slide. I wanted to say that for future endeavors, as I said, I've been interested to invest in this market, and I think there are a couple of other data that I need to kind of make my decision even better, and that's how many nights per year that a place in one location is, for example, empty. That kind of determines the price of the property you want to put out there, and also the mortgage rate and the price of the apartment or land in that location. So I always liked programming. I've never been a professional in it, but this course gave me the chance again to figure out how much I love Python. So I volunteered to enter a data project as a junior data analyst, in addition to my other daily responsibilities in our company. And also, I wanted to thanks Uncommon, our company, to introduce me to this course. Thanks Savvy Coder and LETC to put together this course. Thanks Ashley, you made it easy for all of us, honestly. And also thanks to my wife. Also thank you for your time and attention.
All right. Does anybody have any questions for Amir?
I just want to say that I need that app, Amir. It's hard to pick out a good Airbnb sometimes.
Absolutely, absolutely. Yeah, I have my number in the chat, and you can also find this in the Tableau public. So feel free.
Yeah, that's of interest to all of us. Well, thank you very much.
Thank you.
Okay, next up we have Aurelie. Whenever you're ready.
Hi, everybody. So I'm going to introduce myself before I show my presentation. Thank you for being here and for taking the time to listen to our presentations. My name is Aurelie Capron. I'm originally from France, and I conducted all my studies here in the US all the way up to my PhD. Then I became a university professor. And so I have about 14 years of experience as a professor, teaching, doing research, public speaking, program leadership, and program administration and leadership, excuse me. I also went through a reduction in force layoff, and I thought that was a great opportunity for me to really rethink about a new career. And I was interested in data analytics because I think there are a lot of common points with research. And so I completed the Google Data Analytics certificate. I really enjoyed it, and I decided to get a stronger foundation, and I found Savvy Coders, and this is why I'm here now. I am going to share my screen now. So my presentation is going to be about a pet herbal supplements. You can see Maya here. She's my winter dog. She's almost 14 years, and she has some health issues like all dogs at that age. And I started using some products for her, some supplements, and one particular brand made a great impact on her health. And so when I started with Savvy Coders, I decided that I wanted to be really motivated to do a good job. And one way to do this would be to, create value for a company. And so I reached out to them and told them about what I wanted to do. And they agreed to give me some of their data for me to analyze and see if I could find anything interesting for them. So that's what I'm doing now. So I was given some data from their Amazon online store. They gave me about 40 data sheets. 20 of them were about sales, and the other 20 were about ratings. And they covered every month from January 2021 to August 2022. So I started exploring those data sheets in Excel because I was the most familiar with Excel, but I knew I wasn't going to work with it because I really wanted to practice my new skills in Python and SQL. And so that's what I did. I just got acquainted with the data. I played around with it, like I filtered it, and then I identified some issues to be addressed. And then I got to work on Python. You can see on the left side, this column, that's actually my script. One of the two scripts I wrote, but they are pretty similar. And in that script, I actually did a lot of cleaning. I didn't expect to have to do that much, but there was a lot to be done, which was a wonderful learning experience for sure. And that really helped me to consolidate my foundation in Python. And I actually really enjoyed that. So I'm going to give you a quick summary because there's no way I could go into details. There's just too many things, but I normalized the data differences in product titles. So I got rid of the redundant information and expressions in the titles of the products, just so that I could see clearly. As you can see, right here, the titles were pretty long. And then I really replaced all the names to make them very short, concise. I merged the duplicated data, and some of the columns were identical. Some of the columns had to be added, and others had to be calculated. I dropped the new values, especially when I couldn't identify the product and the product ID was obsolete. I filtered out, all the outliers. And basically, whenever a product ID was just not there, that's when I dropped some of those rows. I converted the data type from object to either float, integer, or string. I removed any kind of expressions or symbols, meaning dollar signs and percentage signs, comma, so that I wouldn't run into complications if I needed to do some calculations. I dropped unnecessary columns. I rearranged the column order, and then I created 2 main scripts. And so I used 20 of my data sheets and they ran through that script. And then I cleaned my data. I used that script, transformed it a little bit so that it would be more appropriate with the second set of my data. And I did the same thing. Once I got there, I transferred everything into SQL, and of course use inner join on there. And I tried to just get 20 data sheets out of the 40. And basically joining them by month. I also had one data sheet that did not want to merge some of the rows. So I practiced it on SQL. I updated some values in my rows in SQL, and then I dropped some rows that I didn't need. Eventually, I went back I went to Python. That's what I of course transferred everything to Python, but I eventually went back to Python after Tableau is what I meant. Because I also wanted to create some other data sheets, kind of pivot the data. And instead of having data sheets per month, I created data sheets per products. And I did that with the first 15 products. I didn't get to do a lot with it on Tableau just because I had already covered quite a bit, and you'll see, but I used some. This is what I have here, all the products that I included in my data, and you can see in that first chart or representation, the products that are the most popular in August 2022, the ones that were sold the most. We see a lot of products for kidney here, for dogs and cats. They are actually the same. And we also have throats for constipations. And a lot of the products that seems to be the most popular are the ones that are 2 ounces. The company also sells the same products, value size, which is twice the amount, but they don't seem to sell as much as the smaller amount. So this is a chart that contains every single product from the month of January through August. And that really gives the company the pulse, I would say, of the product through time. And how many products were sold. I could go all the way down, but I want to stay here. So, maybe we could look at the first one, the kidney product for cats. In January 2021, 1,515 items were sold. And then, for example, here in July, we see that only 700 items were sold. Maybe the company considers that to be normal, or maybe the company would like to kind of investigate and see why there is from twice as little sale as they had in January. So it's the same here for the throat product. Why in August do we have sales that go so low when the 2 months later you have 1,000? I mean, almost 10 times as many. What happened around that time that created such a divide? And we can see that issue with the most popular products here. And we see that a little less as we go down and look at the products that aren't as popular. So it would be interesting for the company to maybe understand what's going on with the product, to maybe cash in a little bit more on their most popular products here. So I wanted to also offer a graph where we had the number of sessions, which is the green, the product value, the sales that they made, which is the red, and also the number of products that were sold in the month of January. So at the beginning of the data sets that I received, just to get a sense of, is there a positive correlation between those three different aspects? And we can tell that, for the most part, there is. And I was curious to see if maybe in August, we would notice the same kind of positive correlation. So this may seem to be obvious, evident, but I think it's always good to check and see if there are some outliers. I also want to mention the number of sessions on Amazon is actually not the same as page views. Page views, if you look at a product 20 times in one day, it will count as 20 times, but the number of sessions will count as just one. It's how many times have you visited that particular page within 24 hours. So that's, I think, gives a better idea of, maybe how many people have come and looked at your product, not how many times total that it's been visited by maybe the same person. So the next slide here this time is only looking at again the amount of products that were sold, but here we are comparing January through August. I mean January with August, and then halfway through October to see if maybe we have some differences from 1 month to the other. Or throughout those 20 months. For example, everything seems to be pretty, sorry, actually it's all in there, to be pretty similar, but we could see, for example, here, if we look at the thyroid for cats, we have 469 products sold in January, and then in October we only have 145, and in August 196. So what is it that caused that product to go down in terms of its sales? And then, so again, this is a graph that could help the company maybe identify some issues with some products, or maybe some patterns that could be useful for them. This graph here is looking at the sessions. So again, the sessions is when the customer is going to the page of the product. And if the customer goes 100 times within 24 hours, it will still count as just one session. So the below graph compares January and October. And if we look at that graph, it appears that January in yellow seems to have, in general, be higher than October. So the products would generally have been visited a little bit more often in January than they would have been visited in October. If we look at the graph that is right above, the January is still in yellow, and it's exactly the same line as the one you see below, but this time it is together with August, and you can see here a difference. So you can see that August has shown really some improvements from January, and that there are a lot more sessions, a lot more customer visiting those pages than in January. So it would be interesting to see, okay, is this something that happens every year? The company has been selling on Amazon for 5 years, so maybe we could see, is it that in October, customers don't really shop so much for products for their dogs because they're too busy with having their kids going back to school, or maybe moving somewhere else different? Is it, or getting ready for Thanksgiving? Or is it something that needs to be noted, and we could see, what happened between those 10 months, and what is it that happened the 10 months afterwards that made the products more popular than 20 months prior. So here we have ratings, and this time I only took the top 13 products within those 20 months. The very first graph is showing you the ratings out of 5 on Amazon. Remember that you either have 1 as 1 star or up to 5 stars. If you don't see a number, it's because I don't have the value for that. And so I'm noticing right away that starting in December 2021, we have more consistent reviews that are higher. If you compare starting from December 2021 to before, we hardly have any values that are 2. Most values here are at least 3.5-ish to well into the 4s, reaching 5, right? Here, it's a little bit less consistent. We have a lot of 2s, we have a lot of 3s. So something took place. And it's interesting to compare that with the number of ratings for those products. They achieved a more consistent and maybe, more consistent at a higher level ratings with having more ratings. So we can see here that they are getting more ratings, and it would be interesting what happened in December 2021 that started to create that difference, and what is it that we can learn from that time to maybe continue that trend so that they can have more ratings and continue to have good ratings. And then finally, this is the buy box percentage. This graph is about those little buttons that you see in Amazon, add to cart, buy now. When you go as a customer to buy a product, you often have those little buttons. We don't always think about it, but the company wants to know whether their button always shows up when we go to the page of their product. Because maybe the button will belong to another seller and the seller will be able to catch the sale, or their button will not be there because their product is out of stock and isn't available. So looking at a graph like this, you can get a way of what doesn't work, because what the company wants to see is 100% everywhere. They want their button to be there 100% of the time, right? So if you start seeing maybe some patterns, and I would like you to pay attention to April, if you start seeing some patterns where it's not the case, right? In April, we have a lot of products that are showing 50% of the time around that amount. So what happened in April that caused the company to not have their button there? Did they have a problem with stock, or do they have issues with sellers? And I'm saying issues because at this time, the company does not allow other sellers to sell their products. So it should only be their button that should appear there. Obviously, there are other, if we look at some products here, maybe dandelion product, what happened in that particular month here that, that made the button appear only 50% of the time, when the month after that, it was there almost consistently. So you can look and compare and contrast, how your products did and what month you had some issues, and maybe figure out a solution so that this doesn't happen. And finally, if you have questions, that's great, but I want to make sure first to thank Savvy Coders. I am so grateful to have gotten to train in data analytics. And I am so grateful from LETC to have gotten, a grant that allowed me to do this, because I would not have been able to do it without it. So thank you very much. And do you have any questions?
Great presentation. I love the buy box screen.
I know, that's why I decided to put it last.
I was actually, I was talking to a client yesterday, and I was telling them about that screen.
Oh, yeah.
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 That was a great presentation.
Thank you.
Again, next time I would put the little dog on every slide, but I get it. You can't do that. All right. Thank you. Okay. Next up is John Unger, whenever you are ready.
So James, do you want to go first? I know you weren't happy about the order.
Oh no, you're good, dude.
Okay.
I've settled in now, man. I'm just like, I'm in viewer mode, so don't jump that on me all of a sudden.
All right. It would have been better, I guess, if I was higher in the lineup. All right, I'll jump in. Good evening, everybody. Thanks for coming. It's awesome that Savvy Coders is able to get folks to come in and kind of take a look at the stuff and make sure that they keep us honest, right? Up the stakes a little bit, make it real. I am the CDO for Alliance Systems, a product development company here in St. Louis. And believe it or not, even though I've been doing this for quite a while, the technologies in this class are tech adjacent to me. They're not things that I've done. It was a bit humbling just how hard some of the coursework was. I spent the first, 8 weeks beating on a very large data set and being very frustrated. I've had a lot of fun. And I'll tell you what, probably the best part of the cohort, and listen, I love the folks that put it on, but probably the best part of the cohort was the cohort because the folks here are going to end up being a network for us going forward and are some really sharp people that are going to do some pretty cool things. So I'm going to go ahead and share my screen and we'll kick this off. Let me find the button here. And let's see here. We will do, let's see if I got the right thing here. Yep. All right. So where it all began. This computer is from 1986. It's the first computer that I purchased with my own money. And it's ironically, I guess, it's the same year that this data set became famous. The setup for this data set is that you're the owner of a Formula One team and you've enjoyed an exciting and volatile year. In every race, you've been on the verge of losing an engine due to gasket failures, but you're still running for a top 3 finish for the season. You have been approached by a new sponsor that will double your budget if you finish this race in the top 3. And you will win the championship and seal the deal. If you fail to finish, you will likely lose not only the new sponsor, but your existing one. So race and win, better funding, bright season ahead of you. Race and lose, you could lose your team because this is your primary sponsor. And without them, you're probably not going to have enough money to compete. You have a third option. If you withdraw, your standings are good enough to keep your current contract and you'll finish your season in 5th. But here's the data. Oh, by the way, this is a little aside. There are programs now that actually do image analysis. And in this image, you can see the tire tracks of the other racers. You could actually run this through an AI or machine learning algorithm to determine the best race line. But anyway, that's not my project. I just saw that and I was like, oh, that would be really cool. But this is the data we have. It's not racing lines. This is where we've had trouble with our gaskets, right? And a couple of things to point out. When we look for blow-by, which is the complete failure of a gasket, the pressure and the force that you're trying to keep inside of something has actually blown through and penetrated the gasket. So this is the first time that we've had like a full failure. Otherwise, the data between damaged gaskets and the distressed or blow-by gaskets match up perfectly. All of these in this nice straight line are really good. These are zeros. These are times that we're able to go out there, push the engine as hard as we want it. Fine, no problems whatsoever. Down here, we see the temperature at the start of the race, right? And it ranges, we've been racing anywhere from 81 degrees all the way down to 53 degrees. What we see here in the distressed area is that it seems like we're having more trouble when everything's cold when we're starting. If we take a linear regression across our observed data for the distressed gaskets, this is kind of what it looks like, and it's obviously it's kind of echoing what we saw in this first area where we tend to have more failures the colder it gets. the blow-by that we experienced was at 75 degrees. And what I found counterintuitive in this data was that by having this blow-by at a high temperature, it actually made our low temperature data look worse. And I didn't expect that. I find it curious. Here's the thing. It's the end of the season. We're well into the fall. It's going to be cold tomorrow. It's going to be really cold. It's going to be much colder than it's been. And we need a crystal ball. We need to figure out what's that line look like when we get beyond the data that we've been able to see. There's a lot of ways to do that. One of the simplest ways to do that is with linear regression. Thankfully, with Python has all kinds of libraries that have all kinds of statistical functions that we can use to take a look at our data set and be predictive, right? And find out what's going to happen later. So in these next two graphs are the same as what we've already looked for, but they've been expanded to allow us to see what happens, at the limits. So in our distressed forecast, and keep in mind, this is just where the gaskets were damaged. We didn't actually have a failure, but when we took apart the engine at the end of the race, we're like, oh, that was close. What we find is that at 30 degrees, we're more than twice as likely. If this linear regression is valid, then we're twice as likely to have a failure, right? And with when we factor in our blow-by, our incident where we actually punctured the gasket at 75 degrees, we find out that we're, at 30 degrees, we're more than 3 times the failure rate. We're almost up to 7 failures. We don't have that many gaskets, by the way. That's really bad. Guess what? We wake up this morning and it's 36 degrees. So we're almost 20 degrees colder than what we've run at. These are our damaged gaskets. This is the coldest race we've run. This is where we're at. We've got a lot of engineers and scientists and people that are really good with numbers on the team. And the sponsor and the money and the next season. And our engineers are saying, listen, extrapolation, predicting outside of what which is the boundary of this red box, that's actually kind of a data error. This is what the SEC warned you about in your mutual funds and your portfolios. Past performance does not predict future, whatever the phrase is, future gains, right? So this whole area is conjecture. So are we going to race or not, right? It's time to, go big or stay home. So let's see here. Where am I? I lost which slide I'm on. So how did it turn out, right? The conversation in the pits is, we already know the answer, right? The boss wants us to go. The boss is really good friends with the new sponsor. We're going to make a ton of money. We're going to buy new engines. We're going to have a better car. The engineers are saying extrapolation is the cardinal sin of statistics. You can't do that. The gasket vendor signed off on this. We're going to lose our funding. If I try to stop this, I'll lose my job. So what do you expect? How did it turn out, right? Well, unfortunately, we weren't talking about a racing team. We were talking about the gaskets on the space shuttle, the Challenger, and the decision to go, the decision to launch resulted in 7 deaths. And NASA didn't race, they didn't race again for 32 months. They were on the sidelines. The failure was so bad that you can see the gantry and the launch tower here. And you can see the blow-by occurred before the shuttle even left the pad. And so a couple of things here, my take on it, right? I think calling the presentation layer of an analytic tool a story is a mistake. And Amir made a point in his presentation You said these are facts, and these are perspectives, and they're subject to your interpretation, and you've got to make a decision on how you're going to present it. And I couldn't agree more. You know, somebody who knew math really, really well found a way to torture the data and make it look like it wasn't so obvious that it was going to blow up, and said, yeah, boss, we can launch. Right. And so everybody in this cohort is a data scientist now. And you're going to be in a room with somebody who should know better, who's going to say, I know what story I want to tell, I just need data for it. And, you know, in case you think this stuff doesn't matter, you know what? 17 years later, NASA did it again. So anyway, I'd like to take a minute to thank everybody, especially our guests. As I said, it's awesome to have some folks from the outside to kind of put a little pressure on, you know, get James Lee to put a tie on. It's good to see James looking sharp. To Elaine, who knew I was wrong and ignored me. And to Ashley, you're incredible. I saw you, I watched you talk people off the ledge over the course of the curriculum. To my cohort, you guys are crazy good. I can't wait to see what you do. To my lovely bride, who I'm going to have to go reintroduce myself to, and to all the instructors and TAs for putting up with me. Thank you, everybody. I really enjoyed it.
Really gives us all something to think about, doesn't it?
I think about it all the time.
I know, it's a sobering ending. It was really, really interesting. Thank you for putting that together, you know, the way that you did. It was really good.
Thanks, Laura.
Okay.
You helped me make it better.
Okay, good. All right, we're going to get to the spiffed up James Meredith now. He is last but never least, and he has a great final presentation.
Maybe I should have went before John. I don't think I can top that ending. That was just like the perfect storybook ending to everything that we did. So, all right, let me hop in here. But nonetheless, I'll go ahead and run through my presentation here for everybody so we can all get out of here and have a cumulative sigh of relief that we're finally done through this 12-week journey. So welcome, everyone. I'll go ahead and get started. Thank you all for those of you who took time out of your day to come here, or for those of you who might be taking time to do so or watch the recording later. I'll go into a little bit about myself, and then I'll dive into my presentation. As you've probably heard, my name is James Meredith. I graduated from Cornell University in 2013. Got the start in my career in digital marketing and sales, and kind of was in business for the first couple of years of my career, and then recently went back to school and pursued education in economics and psychology, and was originally intending to go and pursue a PhD and go into research. And from just a little bit of time pursuing that, realized that life in academia isn't as cracked up to be, as some of you who have treaded in those circles probably know. And so kind of thought that I would like to do things with data. I have always been interested in data and studying real world phenomenon. And so kind of discovered data analytics and discovered Savvy Coders, and was lucky enough to go on this huge 12-week journey along with everyone else. And so without further ado, I'll dive into my presentation for the day. Was going to do something on the economic impact of COVID, but decided that sounded a bit dreary and not quite as fun as doing something on another passion of mine, which is music. So hopefully I can kind of wrap things up on a bright note here. So the kind of essential question that I wanted to answer for my presentation, I decided to do. So what makes a hit song anyway? Like I said, music is a passion of mine. And it's a pretty broad topic, though. You know, you've got your melody, you've got harmony. For those of you who know anything about music, you got lyrics, you got whether or not your artist looks like Harry Styles. That helps a song become popular. and so kind of ultimately I wanted to whittle things down. So for the purpose of this presentation, I'm really just going to focus on this idea of a chord progression. So in songwriting circles, there's this infamous thing called a chord progression. That's a 1-5-4-6 or 1-5-6-4 chord progression. And so there's this it's a crazy urban legend that if you just slap that into your song, particularly in pop genres, but it works in many genres, instantly your song will be, a breakout hit seller. And so, I really wanted to kind of find data to test whether using this particular 1-5-6-4 chord progression would make a song really popular. So that's a little bit of jargon. But it's like I said, pretty infamous in songwriting circles, so much so that it's become kind of a meme. And there's this great band by the name of The Axis of Awesome who wrote a song just highlighting just how much this is actually used in music today. So I'll play a little bit of it for you. Oh, did I remember to share the audio here? Oh, let's see. Give me a thumbs up if the audio on this works. Okay, give me 1 second. Try sharing my screen one more time here.
Look, folks, we've been a rock and roll comedy sensation for 40 years now, and in all that time, we've never had.
We're getting better now.
I know. I would have thought
Cool, thanks.
Guys, you know why we never had a hit?
No. Why?
It's because we've never written a 4-chord song, so we're never going to have a hit.
What is a 4-chord? What's a 4-chord song?
You don't know?
What?
Well, all the greatest pop songs ever written just use 4 chords. I mean, it's the same 4 chords for every song. You want to write a pop hit, just use
4
them.
chords? What chords?
Yeah, just here, these 4 chords. Just 1, 2, 3, 4 chords. That's all you need to write pop songs.
Let me get this straight, Chicken Little. What you're saying is you can take those 4 chords, repeat them, and pump out practically every pop song ever. Is that what you're saying?
Just pay attention. Do you recognize this?
Yeah, that is Don't Stop Believing by Journey.
And the cast of Khalid.
Yeah, there's a few more songs with the same chords. Check it out. My life is brilliant. My love is pure. I saw an angel. Of that I'm sure.
Well, it's just 2 songs, like
people kill and people die and children hurt and hear them cry.
3 songs.
Can you practice what you preach? Won't you turn the other cheek? If I could, then I would. I'd go wherever you will go.
Okay, so hopefully the audio and video on that played well. But so kind of as the video kind of demonstrated, it's pretty popular. It's kind of all over the place. That's what it sounds like. It's in a lot of the songs that you all are probably familiar with. But for those of you who don't have a musical background, let me back up a little bit and kind of explain what we're talking about here, so you know what I'm going to be talking about for the next 10 minutes or so. So let me define a couple key terms for you. A scale is just a collection of musical notes. For those of you who have seen the Sound of Music, you'll know, the famous song Do, Re, Mi, Fa, Sol, La, Ti, Do. That's the major scale. So in this picture here, on the right, we've got what's called a C major scale. Musical notes run from anywhere from A up to G. So in this picture here, we've got a C major scale. Starts at C at the bottom, goes all the way up to top, back up to C. And then a melody is really just a collection of individual musical notes that's usually from a scale. So and then so that's kind of the melody in music. And then there's this, when you think of songwriting, you also think of the harmony. That's really the 2 parts of any song, is the melody and the harmony. So and the harmony is really defined by what chords are used in the song, kind of like what we saw in the video. And so the chords are really just a group of 3 musical notes stacked together, 3 or more. And so in the picture down below here, we've got like a C major chord here. We've got all of the chords that make up the C major scale here. So it's just 1, 2, 3 notes stacked on top of each other. And so the way that chords are defined in the context of a scale is by numbers. So we've got 1, 2, 3, 4, 5, 6, 7, going all the way up to 8. So a chord progression is really just like a succession of like individual chords that kind of really give a song, it's kind of the backbone of a song. It really gives the song kind of its feel and its meaning. And like we saw in the video, it's kind of all over the place. So like I said, I really wanted to investigate whether using this actually instantly makes you a pop millionaire songwriter. So to go into a little bit of the data collection that I did, because this was kind of such a niche technical topic, there really wasn't a data set that existed out there for this. So I really had to create my own. And so I did that by actually accessing this online website by the name of Hook Theory. Hook Theory is an online database of songs that kind of has over 5,000 popular songs that you all are probably familiar of, and then it kind of breaks down the musical elements of those songs. So what I did was I created a Python application here using the beautiful soup library, and it goes through kind of each page and kind of scrapes out the song title, the artist, and the chords that are used in the song. And then ultimately that puts it into a SQL database that you see below here. And so that's kind of the music data. What I really wanted to get at, though, was the popularity of how popular each one of these songs is. And so to find that out, I actually used the Spotify API. So a roadblock that I ran into that, the Spotify API actually is not natively in Python. It's a web-based API, so I believe it's natively in JavaScript. And so I had to do a little bit of Google investigative research and found a library by the name of Spotify that allowed me to kind of integrate this into Python. And so I've got kind of a little bit of a snippet here that you'll see down in the corner that kind of outlines the custom function that I use to scrape the web page. But it essentially looks at each one of the web pages and Hook Theory and kind of scrapes through for the artist, the song title, and the chords that are used in the song. And then actually using the title of the song and the artist, it then does a query into the Spotify API and retrieves popularity information. It then kind of ultimately puts everything into one nice convenient SQL database that you see here. So another roadblock that I ran into, for some reason, in their infinite wisdom, Spotify in their API does not allow you to extract just the raw number of streams that a track has. I really wanted just the total amount of streams, because it's pretty obvious. Millions of streams means a lot of streams, right? So but for kind of fraud protection reasons, they don't allow you to extract that out of their API, just out of fear that an individual, songwriter or content creator might kind of game the system as a way of artificially inflating their song streams. So what they did have was this aggregate number called popularity, appropriately named, and it's a aggregate number from 0 to 100. And so 0 kind of represents not very many streams, and 100 represents somewhere in the tens of millions plus. And then additionally, it's aggregated along with how recent those streams are. So if it's a current song and it's really, really popular, it's going to have a popularity score close to 100. If it's really old and not popular at all, it's going to be close to 0. So and then ultimately, I took all the data and visualized it into Tableau here. So kind of looking at the data set that I used was about 1,000 songs out of the Hook Theory database, and kind of I picked obviously the chord progression in question that we're interested in here, the 1, 5, 6, 4, and then I also compared it against 10 other very commonly used chord progressions. And so in the first chart here, you can see it's pretty obvious that this thing is pretty infamous. There's over 300 songs, so that's like about a third of the sample size that I used of 1,000. have just this one chord progression in comparison to like 10 other ones. So it's definitely really popular or commonly used. And so the next thing I wanted to look at then is, okay, it's really commonly used, but does using this thing actually make your song popular? So again, for that, I looked at the Spotify data and kind of aggregated it here. And if you can see, again, this is, I've kind of kept it on the left here for ease of viewing. If you take a look at it, it's really not all that much more popular than anything else. I mean, maybe slightly popular than some of the more obscure chord progressions, but it's really not allowing these songs to become like breakout hits that the kind of urban myth would suggest. So, you know, that I'm really just scratching the surface with things here. And the sample size is only about 1,000 songs. So, but it kind of debunks the myth a little bit here. And so one thing that I was curious about, kind of delving into further directions that I could take things, would be how kind of the year genre would affect that. So this is obviously it's chord progression that was really popularized in pop songs, like you saw in the video at the start of this presentation. And so I'd be curious to see if maybe different genres would make things more or less popular, or how year or the I guess the decade that the song was released in, how that affected things. In addition, kind of other directions that I could take with things, you know, Spotify has more audio analysis features than kind of what I looked at in this presentation. They actually have a lot of in-house things where you can kind of pull out of their API information on things like the key, the timbre of the song, and then even have other subjective values like how danceable a song is, that sort of thing. So certainly if I had more time to kind of look into this, or was to kind of delve into things further, that's another direction I could take things. And then honestly, the thing initially that I really wanted to do was find a way to audio or analyze the audio of a song directly, and kind of do some kind of interesting data project with that. But unfortunately, that's kind of the beyond the level that we're at with things in this boot camp. So, but I'm really interested in data science and kind of moving on and learning kind of more advanced data science techniques, like natural language processing techniques and that sort of thing. So, you know, if I go on one day and do a data science boot camp, maybe I'll look into revisiting this project and doing something a little bit more advanced. So that's pretty much all I have for you all. Really just wanted to do something to scratch the surface, keep things brief so we could all get out of here and enjoy our newfound freedom now that the boot camp is over. Wanted to take a second, of course, like everyone else, to thank Savvy Coders. You guys have been great. I had like no coding experience prior to this. And so it's been a cool experience in 12 weeks to go from having no idea what I was doing to kind of knowing what I was doing just a little bit more. So that's pretty much it. I'll take questions, and if not, then I guess that's a wrap.
It's great. I didn't know about the 4-chord thing, so you brought it up. Does anybody have any questions for James?
That was great, James. I never realized that a lot of those same chords was used in so many songs that I knew. So I'm actually probably going to try and just pay attention a little bit more to see if like it comes up in anything recent now.
Oh, it's crazy. Yeah, people, it's funny, like pop songs are very like almost formulaic in how they're created. So it's all over the place. Once you know about it, like you'll